Hello, welcome to Flipped. So today we'll be talking about the difference between elements, compounds, and mixture. Okay, first off, we start off with elements, which are pure substances that cannot be broken down into simpler substances via chemical methods. Okay, so for example, decomposition and electrolysis cannot break down elements. Okay, and elements only have one type of atom and has its own unique chemical symbol. So let's take a look at the periodic table here. It's a bit small, but basically everything that has its own chemical symbol is called an element. Okay, so basically if it cannot be found in the periodic table, it's not an element. Okay, so basic unit of an element is called an atom if it's electronically stable, okay, or molecule if it's unstable. We'll talk about this more later in the electronic configuration, but basically elements can exist either in a atom or molecule. Okay, so I've drawn here for you. So this is for example, chlorine molecules. Okay, chlorine molecules. So these two are individual chlorine atoms. They combine to form a chlorine molecule. Whereas here, for example, they are argon atoms. Okay, argon is electronically stable because it's group 0. So it doesn't form any molecule with other elements. So it just exists on its own in gaseous form. Whereas chlorine, because it's unstable, you have to form share electrons with another chlorine atom to form chlorine molecules. Okay, but basically elements can exist in atom or a molecule state. Okay, as such, and elements can be further divided into metals or non-metals or metalloids. Metalloids is not really something that is we will talk about in detail. Basically, metalloids are just elements that have both metallic and non-metallic properties. Okay, so let's just go here first. Basically, these are metalloids. Okay, boron, aluminium, germanium, silicon, etc. Those that fall between the borders here. Okay, all these are metalloids. Whereas everything on the left hand side, okay, are metals. Everything on the right hand side of the border are non-metals. Okay, let's take a quick look at the difference between them. So metals are shiny surface. Okay, for example, like lithium. Okay, it's a silvery in color. Strength of metal is malleable and ductile, means it can be shaped into shapes that we want. Electrical and heat conductivity for metal is that they are both good because they have ions to move them around. And sonorosity is basically how the sound wave can propagate through the whole metal. Okay, is high in metal. Whereas for non-metal side, the surface is a dull surface. For example, you can imagine a carbon, okay, coal like charcoal, okay, it's very dull. It's just black in color, doesn't reflect light. For strength is that it's very brittle. Okay, imagine coal again, charcoal. You can just crush it with your hands. Next one is electrical conductivity. It does not conduct electricity, and it's a poor conductor of heat. So if you heat up one side of it, you cannot really feel it on the other side. Sonorosity, basically sound wave cannot really propagate through non-metals. Okay, and so that's the difference between metals and non-metals. Let's move on to compounds. So compounds are really when two or more elements combine together via chemical reaction. So this is very important, chemical reaction. Okay, you cannot just put them together and call them a compound. They have to they have to actually react together chemically to be called a compound. And compound can only be decomposed back to its constituent elements via chemical methods. You cannot just use a hammer and break it. Okay, it doesn't go back to its element via physical methods. Okay, can only go back via chemical methods. And so because they form bonds, right? They form new bonds in chemical reaction. Okay, they now have different properties between compound and its constituent elements. Okay, due to its change of bonds between atoms. What do I mean? For example, we have water molecule, okay, H2O, which is made up of two molecules of H and two atoms of H, one atom of O. Okay, individually, okay, we know that hydrogen, for example, hydrogen gas is gas, oxygen gas is also gas. But water, for example, okay, it's water at room temperature. Okay, so this is one property between them already. Other properties like, for example, they have different reaction, etc. Okay, so now they have different properties between the compound and its constituent elements, which is what makes up this compound here. Okay, the basic unit of an compound is called a molecule. Okay, and it has its own unique chemical name. So for example, sodium chloride, okay, it's unique, right? It's only sodium chloride has NaCl, okay. For example, hydrogen dioxide, this is something looks very foreign, but it's actually hydrogen, okay, dioxide is O2. Okay, this one don't really exist in nature, okay, but just to write it out for you. Okay, so these are all unique chemical names. Okay, if I were to give you, for example, something like which we will see later, for example, milk, okay, or for example, coffee, can you give me their chemical names? Probably not, right? Because they are just mixture, which we'll talk about later, and they are not compounds because they do not have their own unique chemical names. Okay, so hopefully that's clear for now. And compounds are, okay, if they are pure, okay, what do I mean? If they are free from any impurities, okay, that means there's only one type of molecule there. They have now fixed melting and boiling point. Okay, for more information, you can refer back to our purity of substance video. So what I have for you here are two compounds. First one, okay, is just in this case, for example, let's call them okay, the white one, the one transparent, is element A, and the one shaded is element B, for example. Okay, they chemically react to form this new compound. Okay, and all of them have the same structure. Do you see? These are all A's, these are all B's. Okay, so this is called a compound now. Okay, compound can also exist like this, in this case of H2O, because if you see, there are two H's here, so this one is actually a H, this one is also a H, whereas the middle one is actually a O. Okay, so that's why it's H2O. Okay, and there are many of them, so these are called compounds as well. Okay, whereas for atoms, you can see that, okay, they just look like this. Okay, really, they just have the same kind of element, whereas compounds have different kind of elements. Okay, one shaded, one not shaded. Okay, and these are shaded and these are not shaded. Okay, so that's the difference between compounds and elements for now. Let's move on to mixture. So this is the final one. Mixture is only when, okay, two or more substances, they mix in any ratio. So they don't really care basically, okay, without any chemical reaction. So you can separate them back via physical methods, example, distillation, filtration, evaporation, etc. Okay, you can refer back to our first chapter videos for this. Okay, so for example, latte. Okay, latte is a mixture because it has the properties of its constituent substances. Latte is made out of milk, coffee, sugar, etc. Right? So if I break them up into their coffee component, for example, coffee is bitter. Okay, milk is creamy. So when I add them together, okay, latte is both bitter and creamy. So that's what I mean. Okay, that's an example of a mixture because now mixtures have the properties of their constituent substances. Since substances did not undergo any chemical change. Basically, they are just stirred together in a coffee cup, correct, to form latte. And that's why they have the same properties as they would have in its own original substance. So mixture can also be extrapolated to the idea of elements and compounds. Why do I say so? For example, I have element A. Remember, this is a molecule. Okay, element can exist in molecule, right? Okay, so this is a molecule, this is an atom. Element B is an atom. So when I mix them together, it's called a mixture of elements. So basically, there's A around and there's B around. But if you look at them individually, okay, we do not consider the whole picture. We only consider one individually. So this is an element, this is an element. So together, they are called mixture of elements. Whereas for compounds, individually, they are different already. Okay, one is colored, one is not. Two are colored, one is not. So we know that they are compounds. When we mix them together, they are called mixture of compounds. Whereas here, we know that this is an element because individually, they are the same. Okay, they are both unshaded. This one, individually, they are different because one is shaded, one isn't. And hence, when we put them together, they are called a mixture of elements and compounds, like so. Okay, so this is a very common question which they'll ask you. For example, they give you this final picture here. Okay, they usually put it in a box, okay, like this. Then they'll ask you, oh, label this. Okay, or can be MCQ question, like, is this an element, compound, or is this a mixture of elements, mixture of compounds, or mixture of elements or compounds? Okay, so you have to give the answer accordingly. Okay, so yeah, back to this. So this is, you can see that there's element A here and there's compound B here. So this is a mixture of elements and compounds. Okay, finally, mixtures are not pure. Basically, they have no fixed melting point and boiling point. Sorry, this is my mistake here. This should be like a or, okay? So they have no fixed melting point or boiling point, so they melt and boil over a range. For example, if I were to heat my latte up, okay, my latte is in liquid form, right? If I want to boil it, okay, it won't just boil at, for example, 100 degrees, because we know that water, okay, H2O, it boils at 100 degrees. Am I right? But what about latte? Okay, nobody knows. Nobody knows what temperature it boils at, because it's a range of temperature. Okay, so it will boil at around, for example, 80 to 100 degrees Celsius, for example. It's a range. Okay, and that is true for all mixture, because they don't have any chemical names. Okay, they are really just a mixture of things stirred together. Okay, and for example, a good one will be latte, which has a range of boiling temperature. Okay, and that is all the difference between elements, compounds, and mixture.